কাজের জন্য আসতেই হবে, দরকারই কাজ। কাল 10টায় আমার বাড়ি চলে আসবে। ওকে, ইউ কাম টুমরো at 10. হ্যাঁ আছে। হ্যাঁ yeah, you'll get it. Okay, আমরা একটু ব্রেক নিই না, 1 ঘন্টা পরে চলে। Good evening, everyone. Sorry for the late starting. We are around 10 minutes late, rather say 11 minutes late. We'll give an extended session, and today I will be discussing on statistics, so the kind of things which are very important, and different kind of analytical frameworks will also have in our discussion today. So while the session is going on, you can text me. I'm a little bit sick today, so I will take some cough breaks in the middle. Okay, and the thing is that many of you have done a little bit of workings on probability, but today is an assimilative session on different kind of stuff together. Okay, तो पहले जान लेते हैं कि स्टैटिस्टिक्स में सबसे ज्यादा प्रॉब्लम क्यों होता है. Why in many of the cases, some of you are new today, so let me just give you 1 or 2 important kind of stuff. First, stat, and today is 11/1/24. So let's get started. Today I'm going to do some problems on pre-selected basis. Okay. The first of all, that if it is a very much theoretical approach, just a second, someone who is there. Okay. So here the application based workings. Today I will do some problems on like probability and also distributions. Not so hard, but with every problem you get to see a different avenue is opening in front of you. Okay, बहुत सारे नए सोच के साथ आपको आगे बढ़ना पड़ता है in these kind of examinations. Most the theoretical part needs to be obviously strong. I am not against to that, but theory में ही अगर आप अटके रहेंगे, so that is not again expected. So a little bit of application orientedness is a basic prerequisite in order to crack these questions. Okay, so we know that the theoretical statistics में जैसे सिखाया गया है, kind of derivations जैसे किया गया है, here the logical and analytical framework is completely different. There is a different kind of whole ball game ही जैसे अलग है. Okay, so इस गेम को खेलने के लिए आपके लिए सबसे जरूरी क्या है? Okay, what are the औजार which you have? What are the weapons? What are the armory which you have? So it first is you need to be, which I'm going to say is going to be a little bit astonishing. You need to be good in integration, 2D, 2-dimensional integration and 3-dimensional integration, and beta gamma function. This is a basic prerequisite in order to do it, and also permutation and combination. Nowadays, you remember, I remember a professor at my college, he said that you can do it afterwards. वो ऐसे बीच तक करके छोड़ देते थे. हम लोग सोचते इतना तो कर दिया, इतना तो कर ही लेंगे. But it doesn't happen like that. It never used to occur like that. उसके बाद नहीं होता. Okay. Many of the cases, तब देखते थे कोई ना कोई परम्यूटेशन बहुत बड़ा है, कोई कॉम्बिनेशन का स्ट्रक्चर बहुत बड़ा है, कोई मैथमेटिकल फॉर्मेशन है. समटाइम्स वी हैव टू डू इंटीग्रेशंस. वी न्यू बट ये कैसे एंड तक जाना है, दैट वाज अ लिटिल बिट कंफ्यूजिंग. सो इन माय क्लासेस आई ऑलवेज प्रेशराइज यू और आई से रिक्वेस्ट यू to do it like that. Okay, so let's just finalize one or two things on that first. So for example, if any advanced analysis comes in front of you, let me say if it is a, what is the full form? Anyone know?
Yes, a weak law of large numbers.
Yeah, weak law of large numbers. So this is weak law whenever there must be then SLLN, strong law of large numbers. So when you are dealing with a very relatively respectable huge quantity, there is a problem. There's a functional structurization when you have to do. Now we know that the sample space, whenever the sample space is much more higher, so chances on the probability of cracking any structure is also higher. So as we are going on an integrated format of 3 to 4 basic statistical framework today. So these things will play a very cool role. But what is the basic distinction between weak law and large strong law? Is that the applicability zone. In many of the cases, the weak law can be more than sufficient. In some cases, strong law is less than sufficient. So you can't do it anything. So the basic distinction matters a lot. I have pre-selected 2-3 problems on weak law and strong law based questions as well. So we'll be discussing that. And with every question, I am going to make a point. Okay, we got a question here. Okay, that's good. I need this kind of courageous student. Shruti have asked that I don't know weak law and large numbers. Please, can you clarify this thing? Yeah, sure. I will obviously do it. If any one of you feel that you just don't know and you just tell me, I will do it for you. Okay, so now don't go for the theorem. अगर आप किताब में जाएंगे, Google देखेंगे, they will give you a theory, just like a theorem, और ये theorem समझ में नहीं आता है. How that theorem is been given and very much in a complicated way and everything falls apart. Okay, so now if we say that, just a second. Okay. So for an IID, okay, have a look. IID, independent and identically distributed random variable with finite mean and average. So this converges to mean almost surely. Almost surely. What is almost? So with probability, this probability is very much tends to 1. That's why this is almost surely. Okay, not equal to 1. As the sample size goes, sample goes to infinity. Okay, sample goes to infinity. Okay. So in simpler terms, if you keep taking averages, अगर आप average लेते ही जाएंगे, if you keep on taking averages, of things, आप average लेते रहेंगे. आप लेते हैं, so what is the average intake of food? What is the average number of phone calls you made? What is the average number of street cars are there? So if you keep on taking averages of independent values, or maybe like here tossing of a coin, maybe say independent tossing of a coin, or any other IID random variable, the average value will eventually very close to the expected value. So ये जो हम लोग बोलते हैं ना, probability of getting ahead is half. So this actually tends to half if the sample size S is fairly large. That's it. So this is the weak law. Okay. Now इसी का strong version, I'm saying it's a very much in a basic format में ले रहा हूँ. ठीक है, एडवांस फॉर्मेट भी आज ही बता दूंगा, डोंट वरी, ऐसा नहीं कि सिर्फ बेसिक ही बताएंगे. सो इन द स्ट्रॉन्ग लॉ, Strong law is a stronger version of the weak law of large number and stands for the same kind of sequences. Okay, that is IID. SLLN is also applicable for IID, random variables, and the average converges to mean. Average converges to mean almost surely. Okay, almost surely, I can probability tends to 1 for every subsequence. ये क्या है? Subsequence क्या है? याद रखिए क्या किस 1 2 3 4 dot 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 and 2 4 6 8 दो sequence मैंने लिखा है. Can you tell me which is the subsequence of what? So Sn equal to 2n and Sn equal to n. Can you tell me which one? Sn1 and Sn2. Which one is the subsequence of what? Can you tell me? Give it a try.
Sir, I think SN1 is subsequence of SN2.
Okay. But it's a larger one. Don't you think maybe the opposite may be true?
No, sir. 2, 4, 6, 8 are already in 1, 2, 3, 4, and so on. So I think based on
Yeah.
that logic, it will be subsequence.
Good. Yeah, this is correct over here. So the analysis, if I do it in an easier way, just a second. Yeah. So as we are saying, this as a subsequence, it looks like ये बड़ा sequence, ये छोटा sequence. But actually, this is the super sequence and this is the subsequence. Because this takes into consideration all values. N equal to 1, if you put 1, 2, 3, 4 in that way, all values will come. But in the other way, it will not. Okay. So this is the strong law of large numbers. So this means that no matter what, how much you just you cherry pick the things and all these things, average will still converge to the expected value in the long run. So even if you take the subsequence, if you have a big sequence like this, and if you take a subsequence of this thing with these intervals, but if this thing is also tends to be a large thing, then also this will form into this part. Okay. So for the weak law, it is average converges to mean almost surely, and here average consequence to mean almost surely for every subsequence. मतलब weak law में बोल रहा है sequence के लिए भाई applicable है, strong law बोल रहा है sequence के लिए तो applicable है ही, subsequence के लिए भी applicable. That's it. Both are IID condition is followed, and the strength is can diverge for some sequences and never diverge for any sequence. So that's why it's called the strong law. Okay. It's like an greater than equal to an plus 1 and an greater than equal to an plus 1. So this is that like a strictly increasing function, and the second one is only increasing. Okay, strictly, not strictly, or weakly increasing, you can say. We don't use that term. So every time a little bit of mathematics is being bestowed upon all these statistics. Okay. But yeah, for wider sense, WLLN is mostly applicable almost everywhere, but strong law is not applicable everywhere. So in a wider sense, you can apply weak law of large number. Okay. Next. Okay, let me share the PDF first on screen. Give me a second. So there we go. Let's go for the first question here. So here I have the numbering related issues will be there. So I will be renumbering. First one, pair of a rolling of a fair die, rather say. Pair of a rolling die, I'm saying. Okay. So what will be the approach? So what would be the beginning over here? Tell me, how do I analyze this? So here, it seems to be like a big, tough, hard problem. ऐसा कुछ नहीं है, बहुत ही आसान सा है. तो क्या हो रहा है, एक फेयर डाई है हमारे पास, ओके, जो रोल्ड 4 times independent, जैसा मैंने कहा था. So here independent is this thing, and you can apply the normal Wickler without even applying also you can do it. So the probability that max value of y1 y, देखो यहाँ पर एक फंक्शन है, थोड़ा फंक्शन सिखाते हैं. तो y equal to minimum of a, b ऐसे दिया हुआ है आपको कोई फंक्शन, और आपको बोला है what will be the max value of y. अब कैसे निकालेंगे? Very hard. Just can't differentiate this thing as a dy ta करके minimum. So क्या derivative करके लिखेंगे? There is no function like a square plus b square से दिया नहीं, we can't do it. So here we have to do only one way, that is y equal to minimum of ab. So मान लेते a and b are the left pair of shoes and right pair of shoes. तो आपके पास 5 left pair है, 7 right pair है. So according to this, y equal to minimum of a, b, 5, 7. So what is applicable number of shoes? Y equal to 5 ये आपके लिए applicable है. 5 shoes ही आप इस्तेमाल कर सकते हैं, 7 तो बिल्कुल नहीं, है ना? But now in the other cases, बड़ो classes है. Okay, so in many of the cases, you know what happens? Y equal to 5 is there and this 7. So आपके लिए the best possible situation for you is when both the pair of shoes are same. So y equal to 5 and 7. So this value y will reach maximum if and only if a is equal to b. So the condition is max value of y whenever a equal to b. So there is not a single maximum value, but depending on these two relationships, you can get multiple max. So that is multiple maxima here. But this is a part of this, a bigger interval if you take the minus infinity to plus infinity. So all these different points, you can reach the maximum value with respect to different intervals. अगर इंटरवल अलग अलग लेंगे तो अलग अलग मैक्सिमम मिनिमम वैल्यू आपको मिलता जाएगा. So you can get a different kind of maximum minimum value with respect to every single analytical framework. That's the thing. Okay. Now let's proceed on this. Okay. So now it is easy to see that yi's are IID random variables. So these are all IID RV random variables. With yi, this follows a binomial distribution, isn't it? Okay, 1 if 6 appears ith, so this is a binomial distribution with 1 and 1 by 6. This is n and p, probability, this is n and this is p. And I equal to 1, 2, 3, 4. So then probability of max y1, y2, 3, 4, this equal to also 1. So this is actually max value of this thing, it is 1 minus probability of max. Mathematically we can do equal to 0. So 1 minus probability of yi equal to 0 equal to this, so 1 minus this whole to the power 4. So 1 minus, this is y equal to 0. So that value is not coming. So 1 minus 1 by 6. So this is 5 by 6. Okay. So this is 5 by 6 whole to the power 4. Okay. So that value you can calculate from here. 1, this is 1296, 625, 625, 671 by 1296. That's the answer. ठीक है? हाँ. So 671 by 1296 is the answer. It's almost tends to like 0.5. It says coming 0.625, 0.51. Okay. Next, let's go to this one. Yeah.
Can you explain once how you have written 1 minus that probability is equal to 0, and then 0, how 0 come under the function?
You see, there are only two values given. Either it is 1 or it is 0 otherwise. So 1 is coming with a 1 by 6 probability. And in all the other cases, it is 0 is coming otherwise. So this is the other 5 possible cases. So that is 5 by 6 here. So that's why that is the probability. So if it is y1 equal to 1 value, yi equal to 1 value, if you are looking for, that is 1 by 6. If it is not, then 5 by 6. All the other possible cases will have the same valuation. Okay. Next, number 2. Let X be sample observation from u equal to theta by theta square. Okay. And so it's a uniform distribution here we are having, and where theta follows this, so uniform parameters are being given, and now you are testing the H0. H0 is equal to the null hypothesis. What is null hypothesis? So whatever is perceived according to average or given statement. जो दिया है उसको सही मान लेना ही है हमारा null hypothesis. बाकी उसके अलावा जो भी होगा, that is called the alternative hypothesis. Okay. So now let alpha and beta be the size and power respectively of the test, and we reject the H0 or the null hypothesis if and only if x greater than 3.5. Okay, x greater than equal to 3.5. This value is very important, but we will use it later on. Then alpha plus beta. So first of all, we need to work on some of the basic stuff over here. So what is the most basic stuff? So the PDF, पहले इसको PDF कैसे होगा वो देखते हैं. So PDF, probability density function. So PDF of x. This looks like f of x given theta is equal to 1 by, it's a uniform distribution here we are having. इसका PDF ऐसा होता है, ये थोड़ा जानना है आपको. This is the only thing you need outside of the problem. Okay. Theta square. Yes, you can do it, Ravi, like this. Theta square minus theta if theta less than x less than theta square. Sorry. Theta less than x less than theta square. That is the thing we have given. And the next part is this is equal to any otherwise it's a 0 anyway. There is no problem. So now in this case, if we try to solve this thing, so the value of alpha plus beta. So alpha plus beta is what? Okay, alpha क्या बोला है? Alpha and beta are the power, size of the test and power of the test. Size and power. इसको हम लोग ऐसे लिखेंगे, alpha equal to alpha plus beta equal to probability of rejecting H0 when H0 is true. It's a type of mistake. Okay, when you are rejecting when H0 is true, and then you are rejecting H0, probability of rejecting H0 when H1 is true. Now this is the size of the test, we call it, and this is the power of the test. Okay. Now, next one word is so how to calculate all these things. So यहाँ पर भी calculation का game आएगा. So again here this is set x greater than equal to 3.5. कोई देख के बोल सकता है यहाँ पर infinity होगा कि नहीं? Answer is yes. Here if we integrate this thing, so this will be upper limit will be 3 infinity and the lower limit will be 3.5. So this is like this. Probability of x greater than equal to 3.5 given theta equal to 2. And in the other case, probability of x greater than equal to 3.5 given theta equal to 3. Means x greater than equal to 3.5 can happen in two cases. One is in this case and one is in this case. Both are error. Okay, so this is H0 when theta equal to 2 we have taken, and here theta equal to 3 we have taken. So दो values आ गए हमारे पास. Okay, so next is 3.5 to infinity. 3.5 के ऊपर है, so 3.5 to infinity. F of x given to dx, and this is 3.5 to infinity, just like in the limiting form, x given 3, and this is dx. This is the part done. So now, what is the approachable value over here? X greater than equal to 3.5. Now, where you end up with this thing? Any idea? Have a look. यहाँ पर दो value हमारा theta का दिया हुआ है 2 and 3. 2 and 3. So this value according to the uniform distribution, this is actually lies between theta to theta square. So ये basic theta हमारे पास है, theta square in the first case will be 2 square. So 3.5 and this 2 का square, that is 4. So although theoretically is the limit, but they have restricted us. ये कैसा है? ये it's quite like L'Hopital rule. पहले आपको बोलता है y equal to x square, x1 square and x2 square. Find the maximum value of y, where x1 plus x2 is less than equal to 10. So utilizing these two things, you need to find out the values. Okay, this is the stuff. Okay, so now it is in the other case, ये क्या हुआ 3.5 or theta square, that is 3 square, that is 9. And okay, we don't need to write this value यहाँ पर में होगा. So this is the uniform distribution. So 1 by n is the value. So x by limit. So 3.5 to 4, and this value will be half dx, and this is 3.5 to 9, and this is 1 by 6 dx. Okay, 2 into 1 and 3 into 2. So this is the two values. From there you can very easily calculate. Don't worry, I'm leaving you. If you want, I can do it for you. So 3, 9, 3.5 by 6. Okay, so 156, 7 by 6, 1.167. So the magic of this question, if you don't know how these are testing, then it will be a little bit harder for you. I will do it again, as I'm just giving you a brief roundup of the things, keeping this presumption that you have done this thing. Okay. Now, in this one, there's a probability mass function is been given. So what is the difference between last year हम लोगों ने किया था PDF, अब यहाँ कर रहे हैं PMF. So if it is I will get to the questions. In the meantime, you just text the questions to me 90623 95123 में. Okay. So PDF में क्या हो रहा है? कि जब continuation चल रहा है, continuous variable, so then we integrate, and this PMF for the discrete variables we just do the summation. Okay, that's the difference. So continuous integration always, and for discrete you always do this value. Okay, now there may be some of the cases where a problem can happen. So let me just do some of them. Okay, let me just finish this thing first. So x is a random variable with the probability mass function, or like a PMF. X equal to n is 1 by 10 and 0, n equal to 1 to 10 and otherwise. So then expectation of maximum of x comma 5, just like the way we have done in here, okay, about that shoe problem. Okay, so that we need to apply. Yes, tell me why.
Hello.
Yes.
Sir, I want to ask a question.
Sorry?
I want to ask a question.
Yes.
Sir, आप ऐसे ही पढ़ाओगे अपने कोर्स में या फिर बेसिक से स्टार्ट करोगे?
This will be done. So this is your first session today?
Yes, sir.
Okay, okay. नहीं, आज का एक revisionary session I am doing today. Okay, so on the basis of the different kind of stuff. Okay, so if you have not done this thing, so you can leave it today. Okay, so I will arrange another session with Professor Shubhamal Chatterjee. He will take it on a Friday, that you can do. Okay, if you have not been doing these parts. Okay.
Okay, sir.
Okay. So now let x be a random variable with a probability mass function, and the expected value of the max with respect to x and 5. So here we have done one thing already. Okay. So here we have done one thing already. So that will be done here as well. दोनों ही function को अब एक साथ कैसे लेंगे? That is the thing. So now we have this probability of a random variable, and there is a mass function structure. Okay. So now we have this expectational value. So expectation of this max x comma 5, and with this. So this is like summation of n equal to 1 to 10 max of x comma 5 and probability of x equal to n. Okay. Next, here, how to proceed with this? Any idea?
Sir, I think for n equal 1 to 5, the value of random variable will be 5 itself. And from 6 to 10, it will be the value of x.
Yes, very nicely done. Okay. Yeah. तो maximum value और x और 5 के अंदर बोल रहे हैं. तो अगर वैल्यू मान लो यहाँ 1 to 5 तक होगा, तो ये क्या होगा? Max of 1,5 तो 5 होगा. 2,5 again 5. 3,5 again 5. 4,5 again 5. And 5,5 if I take, then also it is 5. But 6 to 10 में value होगा 6, 7, 8, 9, 10. So from 1 to 5 value is 5. From 6 to 10 value is x. Okay. Next, here we can now come to a conclusion of it. So let's do this. So this is the summation. Max of n comma 5, and this is probability value क्या दिया? 1 by 10 यहाँ डाल देते हैं. This is 1 by 10. So this is 1 by 10 and summation of max of n to 5, 1 to 5, and two values 6 to 10, max of n comma 5. So 1 to 10, 5, and यहाँ पर में सारा वैल्यू हो जाएगा n, जो वैल्यू चेंज होता जाएगा. So 1 to 5 बार 5 है तो 25, and this is 6, 7, 8, 9, 10. 6 plus 7, 13, 21, 40. 65, so 6.5 is the answer. So in that way, the random variable problems can be easily tackled out. Okay. So ये experience आपका होना चाहिए क्योंकि obviously the theory based special session will be on Friday. I'm giving Saturday I'm giving. Okay. So that will be complete theory will be done. But here my target is to give you a glimpse of the things which is actually gonna come. Okay. Next board. Let x1, x2, x4 be an IID discrete random variable जहाँ पर PMF फिर से दिया हुआ है आपको ये निकालना है probability of x1, x2, x3, x4 equal to 6. Give it a try. I'm giving you 2 minutes. कुछ भी हो कैसे भी हो, there's no problem. Okay. So in this one, let me see how many of you sent me. You can just send the starting line. So the given probability mass function can be rewritten. थोड़ा सा rewrite करेंगे इसको, तो ऐसा आएगा. x1 equal to n 1 by 4, 3 by 4 whole to the power n minus 1. If n equal to 1, 2 dot. And this is equal to 0 otherwise. So now, which implies that xi's are IID geometric random variables. ये geometric distribution. So identification of the distribution is very important. इसके ऊपर भी मैं एक special notes दूंगा कि कोई भी distribution को देख के कैसे पता चलेगा. Okay, geometric distribution. So how to differentiate between t-test and z-test? So what are the ways of finding it? Okay, which test to apply, how to do this kind of stuff. So you only know t-test matlab wahi 30 के नीचे less than 30 and in greater than equal to 30. But in many of the cases, the scenario is different. For a relatively smaller case, जहाँ पर 30 भी बहुत ज़्यादा है, even 4 or 5 cases, maybe like this, for maybe nuclear attacks. So there you can't wait till the 30 for a geometrical valuation calculation. So even in this larger or smaller value can be refabricated into smaller structure as well. Okay. Okay. So यहाँ पर में ये है value. So this is the geometric distribution. Here we have directly. Parameter क्या है इस बार? Parameter 1/4 है. ठीक है? This is the thing. So parameter is 1/4. 4 values है. So mass function. So parameter 1/4. Next. So which implies that xi is our IID and generate this valuation structure. So since the sum of it is also an IID geometric random variable, the GRV geometric random variable with parameter probability lies between 0 to 1. तो यहाँ पर क्या कर सकते हैं? So it is this has a negative binomial distribution. अगर नेगेटिव बाइनोमियल डिस्ट्रीब्यूशन क्या है थोड़ा फर्क बता देते हैं. बाइनोमियल में क्या है? आपको 10 में से 6 लगाना है. तो दिस इज द बाइनोमियल. व्हाट इज द प्रोबेबिलिटी दैट यू विल डू? लेकिन अगर उल्टा बोले आपको 6 लगाना है, उसके लिए कितना बार ट्राई करना पड़ेगा? Okay, so n unknown. In that case, it is called a negative binomial, which is exactly happening over here. So binomial and negative binomial, what's the difference? When you know the structure and then you just have to apply, that's binomial. And when you don't know the structure, okay, but you know your target, then how many times you have to apply. जैसे मान लो UPSC exam, 6 attempts are there, you know that. Okay, 6 attempts में से आपको हिस्सा खत्म करना. Like that. Okay, लेकिन यहाँ पर भी अगर ऐसा हो there are infinite attempts are available to you and you can crack the entrance exam. So how many attempts you need in that? Okay. So this is a negative distribution with the parameter n and p. So we have y equal to x4 with an 4, 1/4. Then the PMF y is given by y minus 1, C4 minus 1. This is a negative binomial ka structure. Yeah? If y equal to 4, 5 dot and 0 otherwise. So the required probability is given by four square. So this you can calculate and you can do it from. Next, 5. X and Y are two discrete random variables with joint moment generating. This is an MGF-based question, joint moment generating function. Then probability of 2x plus 3y greater than 1. How this thing can be applicable. So the moment generating function of X and Y, पिछले दिन MGF का class लिया था, Professor Chatterjee. So MXY, MX and Y, t comma 0. To y3 square, where t belongs to R. So it's direct to see that X follows a binomial distribution with 2, 1 by 3. And Y follows another binomial distribution with 3, 2 by 3. So also we have M of XY is a joint distribution of T1 and T2 as Y of T2, and T1 to T2 belongs to R, which implies that X and Y are independent random variables. So the required probability is to 0 or 1. Equal to 1. Independence, you can put it separately. इसको भी अलग अलग से लेंगे. 0, y equal to 0, and this whole thing is plus 0. So this is ये value था the square. No, sorry, this cube. Yeah, this thing square, and this is cube. So 1 minus 2y3 square, 1 by 3 cube, and 2, 4, 9. 2, 4, 3 by 4. So 0.9. So this is the answer in this case. So many of the questions are still be left. So we'll be doing this thing. So I'm going for a brief recapitulation again from the beginning here. So any kind of statistical analysis can be done in this way. And you need to be very cautious about this kind of stuff. In the next session, which will be taken again in this week. So we will be working on MLE based thing. Okay. And also advanced hypothesis testing. Okay. Any questions till now on the basis of the topics which we have done? And I will send you the PDF if you have not managed to copy something, so you can take it from there. Any questions? And anytime, any doubt, any question you encounter anywhere, you can send it to me to the number 90623 and 95123.